Dear student, today I shall discuss about the reaction rate depend on the concentration of the reactant. That is, how the concentration of the reactant influence the rate of reaction. The rate of reaction is depend on the concentration of the reactant. That is, if dx by dt is the rate of reaction is directly proportional to the concentration of the reactant. That is, dx by dt is equal to kc, where k is the rate constant. If c is equal to 1 mole per liter, then dx by dt is equal to k. That is, in 1 molar concentration, rate of the reaction is equal to the rate constant, and also rate of the reaction is proportional to 1 by t time, অর্থাৎ rate of reaction is inversely proportional to the time taken of the reaction. Let us consider a reaction sodium thiosulfide when reacts with hydrochloric acid to form sodium chloride, sulfur dioxide, water, and sulfur will be precipitated. Sulfur will be precipitated. If the concentration of thiosulfate 1 molar, then time of precipitation of sulfur only 10 seconds. If concentration of the thiosulfate is 0.01 molar, then its sulfur time taken sulfur precipitation 98 minutes. That is, when the decreased concentration of the reactant sodium thiosulfate, then the rate of the reaction is also decreases. That is, increase of the concentration of the reactant, rate of reaction is also increases. If we draw a graph, if the concentration of sodium thiosulfate 0.02, 0.04, 0.06, 0.08, 0.1, then 1 by t 0.1, 0.02, 0.04, 0.06, 0.08. That is, rate of the reaction. Rate of the reaction also decreases. At the increase of concentration of sodium thiosulfate, then the rate of the reaction also increases, and this show a straight line which passing through the origin of x and y graph. Get it? That is, and why concentration increases, the rate of reaction is increases, because in unit volume, when the rate of concentration, the amount of the substance is high, when its concentration increases, then the amount of the substance unit place also the unit of the substance, that is the molecule of the substance increases, so that the collision to each other also increases, so that the rate of reaction is also increases. If the substance in a unit volume, the substance of the particle is low, that is dilute, then the particles of the reactant are far distance, and their collision between each other also low, so the rate of the reaction also decreases. And in the concentration, the number of substances concentrate in a unit volume, and their number of collision is also increases, so that their rate of the reaction also increases. And that is the main reason to increase the concentration of reactant, and the rate of the reaction also increases. Now I shall discuss how the temperature influence the rate of reaction. If 10 degree Celsius tapmatra increases, then the rate of the reaction twice. This is the main reason is that when the temperature of the reactant increases, the velocity of the substances in the reactant or the particle of the reactant, their kinetic force will be increases, so that their number of collision increases. And due to this, at the increase of temperature, the rate of reaction also increases. At the increase of 10 degrees Celsius temperature, then the rate of the reaction is double or thrice. According to Arrhenius equation, rate of the reaction is equal to A exponential EA divided by RT, where EA is the activation energy and R is the molar gas constant, T is the absolute temperature. This is the exponential term, where A is the coefficient of temperature and K is the rate constant. Tomorrow I shall discuss about this Arrhenius equation, in what a way it influences the rate of the reaction. Thank you.